Alright, so today we begin chapter 5, which is on polynomials and polynomial functions. So we're going to talk about things that are more than x squared. So today we're going to learn how to classify them and just graph them a little bit, just really basic stuff. So our objectives are to answer the question, what are polynomials? And then we're going to classify them based on degree and number of terms, and then also graph the functions and describe their end behavior. So we have a lot of vocabulary. It's a new chapter. We have to learn lots of new things. So a monomial is a real number, a variable, or a product of real numbers and one or more variables with whole number exponents. So mono means one. The degree of a monomial is one variable. In one variable is the exponent of that variable. So just whatever the degree of your variable is. So if it's x, that would be 1. If it's x squared, it would be 2. A polynomial is a monomial or a sum of monomials, so things added together. The degree of a polynomial is the greatest degree among its monomial terms. So usually you write them in order from highest degree to lowest degree, and then it's whichever one is the biggest. A polynomial with the variable x defines a polynomial function of x, so x is our most common term that we're going to use. The standard form arranges the terms in order by degree in descending numerical order, which is what I just said. So x to the fourth, then x cubed, then x squared, then x, then a number. The degree of a polynomial function affects the shape of its graph and determines the maximum number of turning points or places where the graph changes direction. So when we talk about x squared, how many times did the graph change directions? One time. Well, when we look at x cubed, it's going to change 2 times. So it's, whatever the degree is, minus 1. That's how many turning points there are. Just like the line y equals x has 0 turning points because it's a first degree. This also affects the end behavior of the directions of the graph to the far left and to the far right. So here we go. So this is for classifying. If you have a degree 0, we have a constant. There's an example of 5. One term, it's a monomial. Linear makes a line. That's x plus something. This one has 2 terms. We call it a binomial. A quadratic is an x squared, which is what we just finished up last chapter. In this example, the 4x squared, that's 1 term, so it's a monomial. So you put these things together, it'd be like a quadratic monomial. The next one, 4x cubed minus 2x squared plus x, is degree, it's cubic, and there are 3 terms, so trinomial. X to the fourth is quartic, and then quintic is to the 5th power, and anything more than trinomial is a polynomial of 4 terms, or after quintic you just say 6th degree polynomial. So let's classify some polynomials. So first thing we need to do is write them in standard form. So you rewrite. So 9x squared is first, then 3x, then 5. So 9x squared plus 3x plus 5. Our highest degree is 2, so it's a quadratic, and there are 3 terms. So quadratic trinomial. Alright, how about you go ahead and pause the video right now and figure out these 3. How would you classify them by their name? Alright, I went ahead and put these in standard form. So I have 4th degree quartic polynomial of 4 terms. I have a quartic trinomial, and I have a quintic trinomial. Alright, so what is the graph of each cubic function? Describe the graph, including end behavior, turning points, and increasing, decreasing intervals. So I want you to go ahead and get out your graphing calculator and put in y equals 1/2 x cubed. I'm going to go ahead and get my graphing calculator up on the screen. So if you don't have one, which you should get one, if you don't, you kind of need it, you can see what it looks like. Alright, so in y equals, I'm going to put 1 divided by 2 x, and then raise that to the 3rd power. Alright, so here I have 1/2 x raised to the third power. I'm going to graph it, and then it looks like this. You can see it kind of looks like two half parabolas that are crossing in the middle. I'm going to go ahead and zoom in just so you can get a better idea of what's happening inside here. So you can see it comes up, it stays the same, and then changes direction and goes up again. So what we want to do is we want to make an XY table and compare our values, and then we graph it, and then we describe the relationship. So 1/2 is positive, so it's going to go from the negative to the positive, and since it's an x cubed, it's going to change directions 2 times. So it's going up, and then it stops, and then it's going up again. And if we zoom in a little more, we should be able to see a distinct, well, it's still about the same. So you can tell that it's staying right there. Alright, what about 3x minus x cubed? If you rewrite that in standard form, it's going to be negative x cubed. So what do you think is going to happen? Let me clear this. If the last one was positive and it went up, this one is negative, then it should go down. 3x minus x raised to the third power. Okay, I'm going to graph it. We probably won't be able to see anything because I'm zoomed in so far. Oh, we can see some of it, but it looks just like a line. It shouldn't be a line. So I'm going to change my window from -10. Oops. Okay. -10 to 10. -10 to 10. I'm going to try graphing that. So this one, when we have this 3x, it makes a very obvious transition. So you can see on the graph that there's a very obvious change in direction right here. So that's kind of like what an x cubed does. So we have 2 changes in direction, one here and one here. In the other one, we still have 2 changes of direction, but you can't see them very well because it's like one continuous thing. Kind of did this. And this one, so that was positive, so this one is negative, so it's going to go like this. It's going to be opposite. Alright, so I want you to go ahead and guess what these ones are going to look like before you graph them. And then go ahead and put them on your graphing calculator and see what happens. Alright, these are not going to be exact, but your first one kind of does this thingy. That negative means that it's going to be a negative as its end behavior. This one is positive, it goes up, so this one kind of does that thing again, where it goes up like that. Alright, and then the last thing we're going to do is talk about the difference to determine a degree. So to find the degree of just a set of information, this data, what we have to do is find the difference of y values until our difference is a constant. So we have to take just these y values here and then find the difference repeatedly until the difference is the same. Alright, so what I'm going to do is I'm going to go ahead and rewrite all my y values this way, just because it's easier for me to think about them this way. 5, 11, 9, -7. And then what I'm going to do, difference means subtract. So I'm going to do -1 minus -7. So minus a negative is plus, so that's 6. -7 minus a -3, -4. -3 minus 5 is -8. negative 5, or 5 minus 11 is negative 6. 11 minus 9 is 2, and 9 minus a negative 7 is 16. Okay, we're waiting until we can see that all these numbers are the same. Well, these numbers are obviously not the same, so I'm going to go ahead and subtract again. So 6 minus negative 4 is 10. Negative 4 minus negative 8 is 4. Negative 8 minus negative 6 is negative 2. Negative 6 minus 2 is negative 8. 2 minus 16 is negative 14. Okay, these are not the same, so I'm going to go ahead and do it again until we get the same number. 10 minus 4 is 6. 4 minus negative 2 is 6. Negative 2 minus negative 8 is 6. Negative 8 minus negative 14 is 6. Okay, so we have 1, 2, 3 times that we found a difference. So this would be a third degree polynomial. So that's just a way that you can use data in order to find which degree. So it's going to make one of these kind of shapies. So I want you to go ahead and work on this one. This is what I want you to do for your lesson check. And I want you to work with your partner and show them what degree polynomial you got and how you found it. And that will be your proof that you did your lesson check. So make sure you start your class doing this before you do the worksheet. Alright, so find the degree polynomial, and then your homework is also to do lesson 5-1 on Math Excel. And have a great night.